Hello, everybody. Our presentation is optimization of dose calculation of modified magnetite during sorption purification of water from copper ions to create environmentally friendly technology. The end of 20th and the beginning of 21st century were marked by both scientific and technical achievements and a significant deterioration of the environment as a result of massive pollutions. The state of the hydrosphere is becoming more and more worrying every day. Extraction of copper ions from water with a high degrees of purification, as well as the water purification from other heavy metals, is quite difficult. Known methods of water purification from heavy metal ions are accompanied by the formation of toxic sludge, which is difficult to dispose of, or liquid waste, the processing of which requires significant costs. In addition, most the known methods of water purification from heavy metal ions do not possess the necessary extraction efficiency. The aim of the work was to study the processes of copper ions extraction from water using sorbents based on magnetite in order to determine the optimal condition for modification of sorbents to achieve effective purification of water from copper ions to the maximum allowable concentration. Next slide. To implement the method of sorption water purification, it's necessary to have detailed relationships between the main parameters of the process in optimal conditions. Therefore, the regressions equations were calculated to illustrate the dependence of the sorption capacity of magnetite on the ratio of ferrum-2 and ferrum-3 and the equilibrium concentration of copper ions. If we look at figure, we can say that in this case, the mechanism of activated adsorption takes place. The reason of this is that the copper ions are included in the crystal lattice of magnetite. At low concentrations of copper at K1 to 1 and 2 to 1, almost complete extractions of copper is observed, which can be explained of this mechanism of sorption. In this case, heavy metal ions are practically do not desorb from magnetite without acid treatment and description of the structure of the sorbent. Next slide. Regressions equations were calculated from the dependence of the sorption capacity of magnetite on the ratio of ferrum-2 and ferrum-3 and the equilibrium concentration of copper ions in tap water. The obtained dependence is presented in this figure in the form of plane on which lies the solution of the given equation. The figure shows the dependence of the sorption capacity of magnetite on the ratio of ferrum-2 to ferrum-3 and the equilibrium concentration of copper ions in tap water. Increasing the sorption capacity of magnetite on copper, which increasing the ratio of K in addition to the positive value, has significant disadvantages. First of all, magnetite obtained at K1 to 2 has the highest magnetic characteristics, which simplifies its separation from water, has the highest sludge density and the highest chemical resistance because it has a crystalline structure. As the value of K increases, the contribution of amorphous elements to magnetite increase, which impairs its magnetic properties, reduce chemical resistance, and leads to an increase in the volume of sediment due to decrease in its density. Therefore, to increase the sorption capacity of magnetite obtained at a ratio of K1 to 2, in the process of this synthesis was modified with sodium sulfide. These substances, which are partly included in the structure of magnetite, contain functional groups metal S, which are able to form complex bonds with heavy metal ions, which D metals do not interact with hardness ions and are able to increase the sorption capacity of magnetite. The results shown in figure 3 confirm these assumptions. Modified forms of magnetite are dominated by unmodified magnetite when sorbed from top water. Similar results are observed in the extraction of copper with distillate water. The limiting adsorption increased during the transition from unmodified magnetite to magnetite modified with sodium sulfide. It provides the value of the limiting adsorption at the range of 3032 to 3088 milligram on gram, and is also a very affordable and cheap reagent and quite resistant to hydrolysis and alkali solution. Regression equation for the dependence of the sorption capacity of magnetite on the equilibrium concentrate of copper ions in tap water and the concentration of sodium sulfide were calculated. In this case, we can say that modified with sodium sulfide magnetite is a fairly affordable synthetic inorganic sorbent with high selectivity for copper ions, which should be used to purify water from heavy metal ions. Given the high quality requirements for water purification from heavy metal ions, especially when discharging them into fishery reservoirs or when preparing drinking water, it was interesting to determine the minimum concentrations that can be achieved when using magnetite-based sorbents. When using magnetite modified with sodium sulfide, the concentration of copper was reduced to 5 and 44 milligrams to decimeter in cube at K122, slide 6 and slide 7. At the next slide, we can see fundamental technological circuit of NPP water wastewater purification from ions of heavy metal. The potential application of developing a method of water purification from copper ions is the use of the obtaining sorbent based on magnetite, which allows increasing the efficiency of the process. When using modified sorbents based on magnetite, it is possible to reduce the concentration of heavy metals to milligrams by decimeter in cube. Differentiation given the high capacity of the sorbent in copper ions and the simplicity of its regeneration, it will be possible to implement low-waste technology of water purification from heavy metal during its use. The use of modified magnetite is a cost-effective and environmentally friendly way to purify water from heavy metals. The spent sorbent is utilized at the metallurgical enterprises. Based on the complete spectrum plan, a regression equation is obtained and has a linear characteristic, which allows to optimize the calculation of magnetite dose from efficient extraction of copper ions from aqueous solutions. Given the constant increase in the concentration of hazardous pollutions in water bodies, the next step will be the development of and implementation of the methods for extracting a mixture of heavy metals from water and developing a mathematical model of the process to find optimal distillation parameters. Thank you. It's all.